There's an invisible magnetic force field surrounding our planet, protecting us from harmful solar wind that could annihilate Earth. But this protective blanket is also a swirling ring full of deadly radiation. And to leave Earth's atmosphere, astronauts have to pass through it. The Van Allen belts are rings of energetically charged particles that have been captured by Earth's magnetic field. They got their name from this physicist, James Van Allen. Back in the 1950s, Van Allen launched a Raccoon, a rocket lifted by a balloon above the atmosphere, and it detected the first hint of radiation at higher altitudes. Then, Explorer 1, the first American satellite to orbit Earth, launched January 13, 1958. Explorer 1 confirmed that Earth's magnetosphere was trapping the subatomic particles. The Van Allen belts were the first major scientific discovery of the early space age, and they posed a serious challenge for space travel. High-speed subatomic particles can tear through DNA, increasing the risks of cancer and other diseases. So sending astronauts through these particles is not ideal, and even though they're flying in a shielded spacecraft, doses of radiation can still seep through. But there's no way around the Van Allen belts. In order to reach space, astronauts have to fly through them. First, there's the inner belt, which is comprised of protons. And then the outer belt, which has mostly high-energy electrons. At one point, Van Allen suggested detonating a nuclear bomb in the inner belt to potentially clear out some of these subatomic particles. This plan never happened, but in 1962, the United States did carry out a nuclear explosion in space dubbed Starfish Prime. They wanted to see if detonating a 1.4 megaton bomb in low Earth orbit could augment and expand the Van Allen belts. But the explosion actually ended up temporarily adding more radiation around our planet. So with little success on that front, it was up to NASA to build a spacecraft with a strong radiation barrier and figure out a flight trajectory that avoided the thickest, most radioactive parts of the belt while traveling as fast as possible. Scientists determined that if the speed of the Apollo spacecraft was about 25,000 kilometers per hour, it would take about 52.8 minutes to pass through the belts. Based on that information, they found that the radiation dose received during that amount of time would be, at most, 11.4 rads, and that's without the protection of a spacecraft. And since a lethal radiation dose for a human is 300 rads in 1 hour, NASA deemed the missions a go. In the end, the average radiation dose on the skin of the Apollo astronauts came out to be 0.38 rad, which is about the same radiation you would receive getting 2 CT scans on your head. So while the Van Allen belts are lethal, they could really only kill an astronaut if they were to spend several days in their radioactive vicinity. And despite the challenges the belts create when leaving Earth, we should actually be thanking them for protecting life on our planet from utter annihilation. If you want to see more spacecrafts, check out this playlist here. And be sure to let us know in the comments what astronomical phenomena you want to learn more about. Thanks for watching Seeker. Don't forget to subscribe.